All right, so we have the this little review for exam 3. Um, it's all about taking product rule. It's about differentiability versus continuity. The fact that differentiability implies continuity plus more. You can't expect something to be differentiable anywhere it's not continuous. Okay, so if it's differentiable, it must be continuous. Yes. Okay. Now, it must not have no. Now, again, differentiability is a point-by-point thing, so it could be differentiable over an interval, -1 to 3, right? X in there. But wherever you're saying that word, applying the word differentiable, you're saying, well, no, it must not have any continuities. It may not have any vertical tangent lines, which means it cannot. It must not have corners wherever you're talking about there, and it may not have cusps. It can't have corners or cusps. So you can kind of see as you keep going here that basically, these do not have these are going to be continuous and differentiable most places, if that makes sense. Most, for most x. In other words, if you look at an x, if you look above, the curve is behaving like, nice and smooth. But clearly at -4, -1, here for 3. Now these are just pictures, right? It's important we understand. It's critical. What we're learning is how to connect pictures to text and formulas. -1 is bad, right? So it's differentiable except if x is -1. There's some kind of asymptote thing going on here at 4, and obviously it's 6. You got to have both sides. So if it's the end of an interval, it can't be differentiable there, and it's obviously not even continuous because it didn't fill in. But even if it was, even like right here, that's bad because there's nothing coming from the other direction. It doesn't make any sense to talk about continuity. Now it's bad there, which is -4, -3. There's a hole, right? It can't be, ooh, look at that little cusp. That was easy to miss, but it has a pretty much infinite derivative, or in any event, a corner means the derivative from the left. The slope from the left is like a linear slope, and it's not equal to, that corner means it's not exactly the same, right? It's not the same from both directions. It's like the two different lines there. Everything else looks good except for obviously at 3. And really, these down here, and it's always through me when I was learning, it's really one of those cases where you have to think graphically. I mean, you don't have to, but it's way easier if you're not doing algebra on these. You simply know this is square root of x and it's shifted to the right 5. So if you look at the graph of this, it's basically like something like that. Not great, but so you're fine, right? There's no corner except x not equal to 5. Differentiable except, right? So you say something like differentiable except, just like domain, you say the domain is all real numbers except where there's whatever individual values, except x equals, you could say except x equals 5. It's really the same. The good news is, be it a fractional power with a fraction between 0 and 1, so square root, 2/3 power, as long as you're below 1, between 0 and 1, actually anything below 1, even negative exponents, because they don't even exist when you have, divide by 0. So basically, it's that same thing where you can't have x equal to 2. You can't have x equal to -4. Don't say it. Say it a little bit better. Say differentiable, right? You're differentiable. To answer the question as stated, you say differentiable except for, except at. So in this one is what? What are the roots of this? X squared minus 7. You have to be able to factor quadratics, especially with, 1 in front of the x squared. You know that 12 has factors 4 and 3 that add up to 7, but you want a -7, so they're both negative, which will still give you a positive 12. So x not equal to, those are the places where think about this for a second. The absolute value doesn't care what's going on. It doesn't care about all the drama in here. What it cares about is whatever comes out of that not be, if it's 0, the absolute value is continuous, but you're at that point, the corner. So x cannot be 4 or 3. Those are the only places. Other than that, absolute value is either going to have slope 1 or -1, right? The only one that's perfectly fine for all values of x is number 9, p of x here. It's a polynomial. You can take a derivative of this. I mean, actually, that's for these, except for the absolute value, which is kind of hard. It's -1 is the derivative for x less than equal to 5. 1 is the derivative. So obviously where they meet is absolute values. It's easier to just find 0. But this one, you can take the derivative if you want, and you'll see that it's not going to exist at 0. Well, you take the derivative here, and it clearly exists at 0. It works. There's no denominator. There's no radical in the denominator. That's the problem with this one. It's a -1/3 power when you take the derivative, right? It's x minus 2 using the chain rule to the -1/3. But you put a 2 in here, anything to a negative exponent. The negative is the problem, not the fraction. It's the fact that you started out less than 1. When you subtract 1, you get a negative number, which means you're in the denominator, which means you got a 0 in the denominator at that one spot. Does that make any sense? I don't know. I honestly don't know. I mean, that makes sense to me, but that doesn't help. Okay, now this one is just reminding you, this is a quick reminder, don't forget this is 0, right? There's no, the slope of this, it's a flat horizontal line. I'm going to let you figure that out and plug in the number right. You can take the derivative with the power rule by now. dy dx is the same as f prime. That's really just to remind you that it's, it's just a chain rule problem with, this could have been, y prime, right? You can just say y prime, it's equal to dy dx, Leibniz notation versus other notation. What do? You take the 2, put it in front, x plus 2 to the 1, right? Times the derivative of what's inside, but the derivative of what's inside is just 1. So that really the chain rule doesn't change anything. As long as your x is just a plain old x. If it was like 3x, you'd have a 3 over there. All right, so what do you want? You want h prime, which means you do the thing where you multiply by 3/4. I have the 2 out there, which I write as 2 over 1 just to keep myself from getting confused. And it's 3/4 x to the 3/4 minus 1, right? What's 3/4 minus 1? If you do the math, 4 over 4, 3 over 4. Come on, let's go, folks. We got to know our algebra here. I mean, this isn't even algebra. This is fractions, all right? I know the pandemic, but let's know fractions. To 1 over, so it's 1 over the 4th root of x, and there's a 6 over 4. You can cancel the 2, make it a 1/2, right? 2 over 4 is a half, so you get 3 halves. You can have 3 over, you can obviously ignore the, this was just kind of a placeholder. There's the perfect form of writing it. I'm okay if you just write this stuff here. I'm fine with it. We're learning, but that's what you'll see for answers in like textbooks and stuff if you look at this. All right, let's keep going. Oh, instantaneous velocity, I forgot. Okay, so we got to finish part B. What do we say? 3 over 2, 4th root of, its 4th root is 16. What's the 4th root of 16? You're asking, 16 to the 1/4 power, not times 1/4. For heaven's sake, don't make me age prematurely. You're not multiplying 16 by 4. You're saying, power is a whole different thing. Your brain almost has to have a whole different, you stop thinking normally and you sit and go, okay, what to the 4th power? So if you're trying to find this thing, you call it, I don't care what you call it x, right? You can say, x we just used. Don't call it x, but call it y. I don't call it y. Call it whatever u. Then you take the 4th power of both sides. You don't know what u is. You're trying to find what is that. Take the 4th power, right? And you're really saying, and of course the 4 and the 1/4, you multiply exponents when there's a power all to a power, like something to a power, and then that's all raised to a power. Because it's just multiplication over and over again. 16 is u to the 4th. Well, what number to the 4th is 16? I'm making this look a lot harder than it is. But if you're stuck on this, you've got to really be able to put yourself through this logical process. It's 2 times 2 times 2 times 2 that gives you 16. That's the only number to the 4th. So the answer is, that'll be a 2. Let me change color there. So we got what? 3 over 2 times 2, right? We substitute in that as 2. And you get 3/4. There you go. This one, I feel you should be able to do that. That's t to the 1/2. Okay, so I'm not going to do that one. I'm not going to waste your time and mine with stuff I really want you to be able to do. Now, this one is a, dealer's choice, I guess you call it. You can either FOIL that out quite easily. That's a difference of 2 squares. So in that, if you notice that it's the same thing except with different signs, you just square the first thing minus the square of the second, the 1. So let's take the derivative. It's 8x, and you're done. Get out of there. If you don't know that, you can use the product rule. You can have u and v and do all that stuff. What's a slope at x equal to 16? I went fast there, but I'm moving on. Slow down video, rewind it if you need, and ask questions. What's next? We go to the... All right, so now we've got a clear-cut chain rule. You could FOIL it to... If you really didn't know the chain rule, you could still do it, but I'm just going to use the chain rule. 2, because you could FOIL it times itself, right? You can square it. With the low exponent, you don't have to use the chain rule. You can work it out algebraically. And maybe it'll turn out to be better to do it that way. I don't know. I'm going to do times 2x. You got to put parentheses there, this whole chunk. 2x plus 4, right, is the derivative of the inside, right? You take the derivative, you keep the outside, you keep the inside the same, then you take its derivative and put it back there. Slope at x equals 0. The only thing that survives is this is gone, right? When you plug in 0, you just cross out anything with an x in it, right? So you've just got a 4 times 1 times 2 is 8. All right. I'm tempted to skip this next one. It's just a cube root, which is x to the 1/3. You've done a few of these before. Am I a bad person if I skip that? Am I a bad teacher anyway? It's the 1/3 power, so it's 1/2 x to the 1/3. I'm just going to quickly give you like an answer to it. So it's going to be what? You'd multiply by 1/3, it becomes 1/6 x to the negative 2/3. Do the math on that. 1/3 minus 1, which I'm going to call 3/3. 1/3 minus 3/3 is negative 2/3. So you plug in x equals 8. Maybe that's the hardest part. You end up with 8 to the negative for part B, 2/3. That's 8. What I always do is you split this. You got to think of it as 8 to the 1/3. Now you go backwards and split it, so you write it as this. And, well, there's a negative sign, so then I'll put the you can have the negative 2 there if you want. So once I can find the cube root of 8, well, 2 times 2 times 2 is 8. I'm not going to expect you to know a whole lot of these cubing fourth roots, but 2 and 3. I mean, the answers to these are almost always 2 or 3, or maybe 4 if I'm feeling particularly mean or something, or 5. But it's not like you have a million numbers to try here, and you got a calculator if you want it. So the answer is 2, right? What's the cube root of 8? 2 times 2 times 2 is 8, so 2 to the net. What's 2 to the negative 2? Well, it's simple. It's 1 over 2. Negative signs, negative in the exponents mean 1 over 2 squared. That's 1/4. Okay? Where is it? 1/4. Now, find the slope of this tangent line. This one you could do, I would really strongly recommend you think about this algebraically, right? You just divide each of those by x squared. So you get x to the 4th over x squared. You get, what, x squared minus 3 minus 7 over x squared. If you didn't see what I just did, now each of these has its own derivative. Now, is it a quotient rule problem with v and u and all that? Of course, but I'm not going to do it that way in this case. And then plug in 3. So where are we now? We're getting close to having this worked out. Oh, we got a lot to do. What about the first? Now that one's pretty easy number. I don't know why my numbering went back there. So y is now equal to 20 for the y prime, right? And y double prime just means take y prime prime, and that's equal to 0. F and f double prime, similarly, 13x squared plus 4x is your initial thing. So that becomes 26, right? You end up going down a power and doubling. You take that 2 and say 26, and you get rid of the x. So there's my first derivative for f prime. F prime of x. Now f double prime is simply f prime prime. Do it again. And you get 26. And you can see if you took another derivative, triple prime would just be 0, and every derivative from any polynomial eventually goes to, some derivative eventually. I guess what? If you're starting with a squared, after 3 derivatives, you're at 0. If the degree of the polynomial is 2, by the time you take since you're going down in the highest degree every time, I'm trying to say, you go down by a power each time, you'll be done with all your x powers by the time you get to the second derivative, and then that's a constant, so you're down to the third derivative is 0. That'll always happen. If that made no sense, it doesn't matter. Third and fourth derivatives, this is a sort of a chain rule looking thing, but again, the derivative of the inside is 1. If it weren't something pretty simple, it could be a little bit harder, but this will turn out to be pretty simple. 3x plus 4, I'm just going to do the first derivative, that's g Oh, be careful here. G prime, I made a mistake when I did this in class. G prime is this. So G double prime, you already have G prime. They're kind of messing with you a little bit, like read carefully. Those primes are small. You go down by one, you go down by another, right? Oh, and of course the chain rule, there's only a 1 comes out of this. So you're still 6x plus 4 to the 1. And you could use the chain rule, or you could just multiply 6x plus 24. G fourth, you can write it Roman numerals, or you can do 4 slashes is equal to 6, right? Take the first couple derivatives of that, very similar to what I did already. I'm going to let that go. I think you can do the next one. I think you can do, yeah. Well, we only have, well, I think we already did number 7. So I'm just going to do this thing. So you have t to the 1/2, right? T to the 1/2. I just write arrows and I just say, when you do the operator d dx, it's like an operator. It hits, you act upon this. You say, well, there's the input to the operator. What you get is 1/2 t to the negative 1/2, right? That's what you do. Then you do it again. You say second derivative, I do another d dx of that thing. And the cool thing is, it's just negative what? Negative 1/4. 1/2 times 1/2 is 1/4. And then negative 1/2 minus 1 is negative 3/2, right? You got 2 more negative halves. And if you want to write like a textbook, you go like for, what is that? It'd be like, they might just say t to the 3/2. You can use square roots and cubes and stuff, but that's good. All right, I hope that helps. Peace out.